Welcome back to Coder Beans. Basic example. Function fetch data callback. Simulating an asynchronous operation. E.g. fetching data from a server. Set timeout. Const data equals fetch data. Console.log after 2 seconds. Callback data. 2000. Function process fetch data. Console.log data. Console.log end. Console.log start. Using the fetch data function with a callback. Fetch data, process fetch data. Console.log, processing data. Console.log, do something else. Output. Start. Processing data. Do something else. After 2 seconds. Fetch data. End. Right-click in VS Code and select Run Code. You will get this output. Start. Processing data. Do something else. After 2 seconds. Fetch data. End. Asynchronous programming in JavaScript. Get ready to learn some cool stuff about JavaScript in our latest video series, Learn JavaScript Step by Step. In Part 9, we're diving into asynchronous programming, which is all about handling tasks in JavaScript in a clever way. What you'll learn. 1. What is asynchronous programming? It's a fancy term for doing multiple things at once in JavaScript, which is super important for making websites fast and responsive. 2. How JavaScript works. We'll talk about how JavaScript manages to do all these things at once, even though it's technically just one thing happening at a time. 3. Callbacks. We'll explore a special trick called callbacks that helps us do things like loading web pages or handling user clicks without slowing down the whole program. 1. Introduction to asynchronous programming. Definition. Asynchronous programming is a programming paradigm that allows tasks to be executed independently without waiting for the completion of previous tasks. It is crucial in web development, where operations like fetching data from a server, handling user input, and performing other tasks need to occur without blocking the main thread. Synchronous versus asynchronous. In synchronous programming, tasks are executed one after the other in a sequential manner. Each task must complete before the next one begins. This can lead to blocking, especially when dealing with time-consuming operations. Asynchronous programming, on the other hand, enables tasks to run independently. Instead of waiting for one task to finish before starting the next, the program can initiate a task and move on to the next one, checking back for results later. Examples. Let's consider a simple example to illustrate the difference between synchronous and asynchronous code. Synchronous code. Write this code in a script.js file in VS Code. Console.log start. Function sync operation. Write a for loop which writes console.log sync operation 3 times in console. 4. Let I equals 0. I less than 3. I plus plus. Console.log. Sync operation. I. Sync operation. Console.log end. Output in console will be start. Sync operation 0. Sync operation 1. Sync operation 2. End. Right-click in VS Code. You will see this output in terminal output. Start. Sync operation 0. Sync operation 1. Sync operation 2. End. The synchronous function sync operation runs entirely before moving on to the next statement. Asynchronous code. Console.log start. Function async operation. Set timeout equals a console.log async operation. 2000. Async operation. Console.log end. Output in terminal will be start. End. Async operation. Right-click in VS Code and then select Run Code. You will see this output in terminal output of VS Code. Start. End. After 2 seconds. Async operation. In this asynchronous code, the console.log will first print start, end, and then after 2 seconds it will print async operation. The async operation function initiates an asynchronous operation using setTimeout. While waiting for the timer to finish, the program continues to the next statement without blocking. Real-world scenario. In web development, common asynchronous operations include fetching data from a server, AJAX requests, handling user input, click events, keyboard events, reading/writing to a database, animations and transitions. 2. Understanding JavaScript's single-threaded model. JavaScript is a single-threaded, non-blocking, asynchronous language, and understanding its single-threaded model is crucial for effective web development. In a single-threaded environment, there's only one execution thread, meaning that only one operation can be performed at a time. This is in contrast to multi-threaded environments, where multiple threads can execute simultaneously. Key concepts. 1. Single thread. JavaScript runs in a single thread, meaning it has one call stack and one memory heap. The call stack is a data structure that keeps track of the function calls. It operates in a last-in, first-out, LIFO manner. 2. Event loop. To handle asynchronous operations, JavaScript uses an event loop. The event loop continuously checks the call stack and the message queue. If the call stack is empty, the event loop takes the first message from the queue and pushes it onto the call stack, initiating the associated function. 3. Callback queue. Asynchronous tasks, like timers, network requests, and user interactions, are handled through callbacks. When an asynchronous task completes, its callback is placed in the callback queue. Example. Consider the following example to illustrate the single-threaded nature of JavaScript. Write this code in script.js file. Console.log start. Set timeout. Console.log after 3 seconds. Console.log timeout 1. 3000. Set timeout. Console.log after 3 seconds. Console.log timeout 2. 6000. Console.log end. Output. Start. End. After 3 seconds. Timeout 1. After 3 seconds. Timeout 2. Right-click in VS Code and select Run Code. You will get this output. Start. End. After 3 seconds. Timeout 1. After 3 seconds. Timeout 2. In this example, the first console.log start is pushed onto the call stack and executed. 2 setTimeout functions are encountered. They are asynchronous and their callbacks will be executed later. The event loop continuously checks the call stack. Since it's empty, it takes the first callback from the callback queue and pushes it onto the call stack. The setTimeout functions have a delay of 3000 milliseconds and 6000 milliseconds respectively. Their callbacks are deferred and placed in the callback queue, allowing the main execution to proceed. Real-world scenario. Understanding the single-threaded model is crucial for writing non-blocking code in web development. Common scenarios include handling user interactions without freezing the UI, managing AJAX requests without blocking other operations, executing animations or transitions asynchronously, JavaScript's single-threaded model, coupled with asynchronous capabilities, allows developers to create responsive and efficient web applications. 3. Callbacks in JavaScript. In JavaScript, a callback is a function that is passed as an argument to another function and is executed after the completion of a specific task or event. Callbacks are fundamental to asynchronous programming and are commonly used for handling events, making HTTP requests, and other asynchronous tasks. Basic example. Function fetchData callback. Simulating an asynchronous operation. E.g., fetching data from a server. Set timeout. Const data equals fetch data. Console.log after 2 seconds. Callback data. 2000. Function process fetch data data. Console.log data. Console.log end. Console.log start. Using the fetch data function with a callback. Fetch data, process fetch data. Console.log, processing data. Console.log, do something else. Output. Start. Processing data. Do something else. After 2 seconds. Fetch data. End. Right-click in VS Code and select Run Code. You will get this output. Start. Processing data. Do something else. After 2 seconds. Fetch data. End. In this example, 1. The fetch data function simulates an asynchronous operation using setTimeout, which sets a time of 2000 milliseconds, which equals to 2 seconds. 2. It takes a callback function, process fetch data, as an argument. 3. After the asynchronous operation is complete, which takes 2 seconds, it invokes the callback with the fetch data. Handling sequential operations. Callbacks are often used to handle operations sequentially, especially in scenarios where one operation depends on the result of another, like this. Write this code in script.js file in VS Code. Function step 1 callback. Set timeout. Console.log after 2 seconds. Console.log step 1 completed. Callback. 2000. Function step 2. Set timeout. Console.log after 2 seconds. Console.log step 2 completed. 2000. Sequential execution of steps. Console.log start. Step 1, Step 2. Right-click in VS Code and select Run Code. You will get this output. Start. After 2 seconds. Step 1 completed. After 2 seconds. Step 2 completed. Here, Step 2 is passed as a callback to Step 1, ensuring that Step 2 is executed only after Step 1 is complete. Callback hell. One challenge with callbacks is the potential for callback hell, also known as the Pyramid of Doom, where multiple nested callbacks can make code hard to read and maintain, like in this example. Write this code in script.js file in VS Code. Function fetchData callback. Console.log fetching data. Set timeout. Const data equals fetch data. Callback data. 1000. Function process fetch data data callback. Console.log after 1 second ready to process. Set timeout. Const process data equals data dot to uppercase. Callback, process data. 1000. Function display result. Console.log after 1 second, result. Nested callbacks. Fetch data. Process fetch data, process data. Display result, process data. The output will be fetching data. After 1 second, ready to process. After 1 second, result, fetch data. Right-click in VS Code. You will get this output. Fetching data. After 1 second, ready to process. After 1 second, result, fetch data. Advantages. Asynchronous operations. Callbacks enable handling asynchronous tasks effectively. Flexibility. They provide flexibility in defining behavior after a specific task completes. Event handling. Callbacks are commonly used for event handling. Disadvantages. Callback hell. Nested callbacks can lead to less readable and maintainable code. Error handling. Error handling becomes complex, especially in nested callback scenarios. In modern JavaScript, alternative approaches like promises and async await have been introduced to address the challenges associated with callbacks. Stay in the loop with the latest coding tutorials, tips, and community chats. Subscribe to Coder Beans and join us on our coding journey. Subscribe now. Coder Beans YouTube channel. Ready to dive into the exciting world of JavaScript? Let's code together and make awesome things happen.